Okay, so some updates on the lighting. This area here, which is the basking zone, is now more luminous. Okay, so we have the um, UVB, the heat lamp, and the LED bar at the back. And then this cooler end here is more sort of like shadier. Um, and the plants should, although this side is more densely planted than that side, they're mostly succulents anyway. These are. Um, this one is an asparagus fern, so they're pretty tough anyway. They're common sort of house plants. So they should be that should hopefully be okay there with a little bit less light. But what I want to do is I'm testing a couple of bulbs to measure the ISO irradiance, so the kind of like power density of the light concentrated in that area. Um, so basically, looking at the radiation, which is of benefit to reptiles, more so than just concentrating on getting a particular temperature for a certain spot or area. Okay, so the radiation, which is like the wavelengths of photons, so light energy coming from the basking lights, you know, the lighting provision here. So what is more important than achieving a certain temperature is the sort of concentration of the radiation. Okay, so like the UV, the UVA, the infrared, and UVB. Okay, and the visible light as well. Okay, so this meter here measures the power density. Okay, in watts per square meter. Now, studies have been conducted and conclude that as a safety sort of measure, um, the aim for the power density is to achieve around 200 to 350 watts per square meter. Okay, given at around about a 30 centimeter sort of range from the top of the basking bulb. Now, I'm using at the moment a Par30 75 watt frosted beam flood lamp, which, as we can see, temperature wise, so it's warmed up that area to 31 degrees and has decreased the humidity. This sensor here is picking up temperatures of 33 Celsius ambient with a humidity of 42. But that's only what it's picking up in this like immediate area around it. Then we have this thermometer sensor here, placed away sort of from direct radiation, and that's picking up temperatures of 32 Celsius. So we can sort of, you know, say that that's okay for the basking sort of area, and it kind of it sort of fits in with the deserty kind of theme. Okay. But what I want to do, I've also got a couple of bulbs here that I want to test, but I'm not going to have time to do that now. But over the course of the next couple of days, I'll be testing these to see what sort of power density these provide to the basking area. Okay, so we have a 40-watt basking spot. I think this is just a tungsten filament, not a halogen. And then we have a 60-watt. And then I do have a couple of halogen bulbs available as well that I'll be testing. And the one I also want to test, pardon the beetle, you stay in there, making a mess. So anyway, without further ado, I'm just going to go straight into it and whack this. So from the top of the mesh, bearing in mind that there is a heat guard on the bottom of this clamp reflector, and in that reflector is the halogen bulb. So if I place the sensor under here, we can see we're getting a reading of about 270-ish, okay, which is within the 200 to 300 watts per square meter, which is perfect, okay. If I move it over to here, where there is a lot of shade, we can see there the power density is only 15 watts per square meter, but that's fine, okay. So we can tell if I place it under the UV here, can't really see because of the shade. If I place it by here, we can see there's only a little bit of power density coming off that, but that's fine. So there's obviously a lot of infrared energy coming from this light, from the heat light, which hence the higher watts per square meter power density, okay. And that is the figure that we're sort of aiming for, between 200 and 350 watts per square meter. So you can see this here, that little symbol there measures watts per square meter. What's the word? That resembles the power density reading, okay. So we have a good amount of radiation coming from the light sources in the basking area through the visible light, the infrared light, and the UVB, okay, as well as like a bit of UVA, which is beneficial to reptiles, okay. So if you need the reference for that information where I got the 300-watt guide from, the article is available on the Advancing Herpetological Facebook group and also the Reptile Lighting group, which are both accessible on Facebook. And the article is by Roman Murin, and the title of the article is Basking in Infrared version 11. So it'll be in the file section in those groups, amongst lots of other articles as well, to do with power density and reptile lighting, okay. So for further research, in order for you to make an informed decision on your own lighting choice for your reptile, do head over to those files on those groups, and I will keep you posted on the updates with these guys, and then I can make my own informed choice as to which one would suit this best. Okay guys, that is all for now. Thank you.